We are going to solve topical past paper questions of paper 2, topic measurements and physical quantities. So it's a past paper question of 2014 May June series. Course code is 9702. Starting with the first question, a coin is made in the shape of a thin cylinder as shown in the figure. Okay, this is the figure, its thickness is given, its diameter is given. Okay, what we have to find, we have this table in which there is a mass, thickness, and there is a diameter. We have to find the density. Okay, so density is equals to mass divided by volume. Okay, and volume of a cylinder is pi r square multiply by its thickness. Okay, but we don't have radius, we have a diameter. So as we know, r is equals to d by 2. Putting this value, we get v is equals to pi d square divided by 4 into t. Okay, so this is a relation for the volume. So density will be equals to mass divided by pi d square t divided by 4. Putting the values, we have mass is given, that is 9.6. You have to convert this 9.6 into grams, into kg. So 9.6 divided by 1000. Okay, and for thickness it's in millimeters, so 2 divided by 1000, and diameter is also in millimeter. You have to write down your answer in kg per meter cube, so you have to convert all the units. It is 22.1 divided by 1000. Okay, so this expression will become 4m pi d square t. Putting the values, we get 4 into 4 into mass is 9.6 divided by 1000, and I'm going to put the value of pi is, and d square is basically 22.1 square, and 1000 will go above. Okay, and for t, thickness is 2 and 1000 will go there. Okay, so this will give you 12513 kg per meter cube. Okay, so this is the answer for the density. Calculate the percentage uncertainty in the density. Okay, so density formula that we have calculated is this one. So basically density is 4m divided by pi d square t. So I can write it as density is proportional to mass. I'm going to remove the constants, the numbers only, m d square and t. Okay, so the rule for the percentage uncertainty is whenever the quantities are multiplied with each other or divided by each other, their percentage uncertainties will be added. So what I need percentage uncertainty of m, percentage uncertainty of d square, and percentage uncertainty of t. Okay, I need these, and then we have to add them, and then percentage uncertainty of density will be percentage uncertainty of m plus percentage uncertainty of t square plus percentage uncertainty of t. Okay, this is the basic procedure that we are going to do. So finding the percentage uncertainty of mass. Okay, for the percentage uncertainty units, you don't need to convert the units. Okay, we can use any units, the answer will be the same. So its density is, for mass, uncertainty is 0.5, and the made value is 9.6. And it's 0.5 divided by 9.6 multiply by 100%. Okay, and this will give you 5.21%. Okay, for the d square, so there you have to apply the power relation. So power will be multiplied with the percentage density of d. Okay, so you have to multiply this with 2 multiplied by 0.01 divided by 0.01 is this value, and divided by 2 multiply by 100. Okay, so this will give you 0.905%. Okay, and for thickness value, uncertainty is 0.1, and this is the actual value. It's 0.1 divided by 22.1 multiply by 100%. This will give you 0.50%. Okay, so adding all of these three values, you get 6.6%. Okay, so 6.6% is the answer. At the end, state the value of density with its actual uncertainty. Okay, so we know that you have to find the actual uncertainty, and the value is already calculated, that is 12513. Okay, so we know that in 1 we have to find 6.6% of 12513. That will be 6.6 multiplied by this number divided by 100. Okay, so this will be nearly 800. Okay, so your answer is 800. Okay, so we are starting next question. It's 2014 October November. Mass and length and time are SI base units. State any other two base units. Okay, so other two base units can be taken as current and temperature. Okay, a mass is placed on the end of a spring that is hanging vertically as shown in the figure. The mass is made to oscillate vertically. The time period of the oscillation of the mass is t. The period t is given by this relation. C is a constant, K is spring constant. Show that C has no unit. Okay, so first of all we have to solve it for the C. So make C as a subject, M over K. So I have to shift this under root. This under root will go on the left side, so it will become C is equals to T under the root K over M. Okay, it will be, we can take the reciprocal of it. So now putting the units for the C, we get C is equal for T was, what was the T? T was the time period. So for T it is seconds. Under the root K is spring constant. Okay, so spring constant from the Hooke's law, if F is equals to Kx and K is equals to F by X. So spring constant is Newton per meter divided by mass. Mass is kg. So these are the units, we have to simplify them. Okay, so S Newton, we know that Newton is equals to, Newton is force, kg meter per second square. So it is kg meter per second square. This is for the Newton, and already there is a meter, and this kg can be written as kg minus 1. Okay, whole power 1 by 2. Okay, so S. This will be, this kg and this kg will be cancelled out. This meter and this meter will be cancelled out, and this S minus 2 power 1 by 2. So this will also be cancelled out. So this will give you S into S minus 1, and that will be equals to 1. Okay, so it's no unit. All the units will be cancelled. And the third question, define pressure. Pressure is simply force divided by area. A cylinder is placed on a horizontal surface as shown in the figure. The following measurements were made. Okay, this is the mass and the diameter is also given. Calculate the pressure produced by the cylinder on the surface. Okay, so for the pressure you need a force. In that case, force is the weight of the cylinder. Okay, so we have mass, so weight is equals to mass m times g. Okay, g is 9.81 Newton per kg. And for finding the pressure, you need to find the area of this surface. Okay, that is on the ground. So it's this area will be, area is pi r square. Okay, and or if you want to write down in form of diameter, it will be pi d square divided by 4. Okay, so finding the pressure, P is equals to F over A. F is mg, that is the weight, and A is pi d square divided by 4. Putting the values, mass is 5.09 into 9.81. Mass diameter is 9.4 square divided by 4. So that will give you 7195. That can be written as 7200 Pascal. So 7200 Pascal is the answer. Okay, calculate the actual uncertainty in the pressure. Okay, we have to find actual uncertainty, but for finding actual uncertainty, first we have to find the percentage, because these terms are, the mass and d are multiplied with, are divided with each other. Okay, so you have to find percentage uncertainty first. So how we can find it? Okay, so percentage uncertainty in pressure is equals to percentage uncertainty in mass plus in this d square. Okay, there is a power 2 as well, so you have to multiply with the power 2, delta d divided by d. Okay, so putting the values, m is 0.01 divided by 5.09 plus 2 into 0.1 divided by 9.4. Okay, so that will give you 167. Okay, 167, or you can roughly say 170. 170 if you round it off. So state the pressure with its actual uncertainty. You just have to write down the calculated value. 7200 was the actual value, and 170 was the uncertainty. Okay, pascals. In question number 4, the Young modulus of wire is given. Its value is this. The wire is extended and the strain is this. Calculate the stress. Okay, so we have to use the relation of Young modulus. Young Modulus is equals to stress divided by strain. So stress is equals to Young modulus multiplied by strain. Okay, so Young modulus was 1.8 into 10 raised to power 11, and strain is 8.2 into 10 raised to power minus 4. So multiplying both of them, you get 0.148 gigapascal. Okay, gigapascal, I mean the answer will be 1.476 into 10 raised to power 8. Okay, that is converted into gigapascal because you have to write it down in these units. Okay, so finding the wavelength. An electromagnetic wave has a frequency of 12 terahertz. Calculate the wavelength in micrometers. Okay, so you have to use wave equation. Wave equation is V is equals to F lambda. So lambda is equals to V by F. Speed of electromagnetic wave is equals to speed of light, and frequency is 12 terahertz. 12 into 10 raised to power 12, that will give you 2510 raised to power minus 6 meter. That can be written as 25 micrometers. Okay, so 25 micrometers is the answer. State the name of the region of the electromagnetic spectrum for this frequency. It is in infrared region, that is called IR. Okay, an object is on a horizontal surface. Two forces acts on B in this horizontal plane. A vector diagram for these forces shown scale in figure 1.1. Okay, but we have to do a force of 7.5 Newton towards the north, and force of 2.5 is 30 degree north of east acts on B. Okay, the mass of the B is 750 gram. So mass of the B is also given. Okay, draw an arrow to show the approximate direction of the resultant force of these two forces. Okay, we have to draw approximate direction of these two forces. Okay, so first of all we have to use a head to tail rule. This, let's suppose this is the F1 and this is the F2. As we have to draw the approximate, so there is no need to measure. First of all, take this force as a 1 in the north direction. This is 7.5 Newton. Okay, and we have to place the second force, this one, on the head of the first. So you have to draw the second force on the head of the first, keeping the same direction. So it's 30 degree. It's 30 degree. Okay, so this is F2. Resultant will be from the tail of first to the head of last. So this is the expected resultant. So resultant will be, we can draw the resultant on the diagram in this direction. Okay. Resultant force, and draw an arrow to show the now show that the magnitude of the resultant force on B is 6.6. Okay, for resultant force we have to make the diagram on scale. On scale diagram mean you have to draw the diagram. First of all, choose the scale. Force 1 is 7.5 Newton, and let's suppose 1 centimeter is equals to 1 Newton. Okay, so first of all we have to draw 7.5 Newton in the north direction. Okay, this is the force 1 and this is the force 2. So it is take a scale and draw a 7.5 centimeter line in the north direction. Okay, this is force 1. Now we have to draw a second force at 30° north of east, act on the B. North of east, so you have to draw a 30°, take a D and measure the angle approximately. That will be not approximate, it's actually it should be 30° with the x-axis. So 30° with the x, let me redraw it. Okay, so let's suppose this is the imaginary x-axis and we have to draw 30° with the x-axis. So this should be, take a D and measure the 30° angle and draw a line there. Okay, and its length should be 2.5 centimeter. Okay, this was the first vector is this, second is this, and resultant will be from tail of first to the head of last. Okay, now take a scale and measure this length from this point to this point. Whatever the length is, this will give you, this will be on scale equals to 6.6. Okay, if you measure on the scale, it will be equals to 6.6 centimeters. So 1 centimeter is equal to 6.6 Newton. Okay, calculate the magnitude of the acceleration of B produced by the force. So we have to calculate the magnitude of the acceleration. So we know that acceleration is equals to force divided by mass. Force is 6.6, mass is given 0.75 kg, so that will be equals to 8.8 meter per second square. Determine the angle between the direction of acceleration and the direction of the 7.5 Newton force. Okay, so this is the 7.5 Newton force, this one, and the acceleration direction will be the direction of resultant force. Okay, so this is the direction of resultant force. You have to measure the angle, so you have to measure this angle from with the